Hello, and welcome everyone. We're going to do a little special video here. We're going to do a look at programming the Arduino, not using the standard Arduino IDE, but actually using Microsoft's Visual Studio. And we're going to also look at using a plugin from a third party called Visual Micro. And we're also going to set up GitHub so that we can have a online backup and share our files with other folks. So with that, let's go ahead and get started. I'm going to peel my eyes over to the other computer because Visual Micro and Visual Studio only works on Windows. So my machine that's Windows is over here, so I'm going to tilt my head a little bit, but hopefully you'll bear with me with this. So the first thing, you want to go ahead and head over to visualstudio.com and download the Community Edition. And at the time of this filming, it was 2017 was the latest version. Again, there is Visual Studio for Mac. However, as of right now, the third-party plugin for Visual Studio or Visual Micro doesn't work yet. At least I can't figure out how to make it work. So if you do know how to, let me know. But for right now, we're going to use the Windows base. We're going to use Windows, the Community Edition of Visual Studio 2017. Then we're going to download Visual Micro from visualmicro.com. There is a free version and there's also a paid version so that you can do, I think, and they've just changed recently what was included in the free version and what's now in the paid version. And then lastly, GitHub, their desktop client, they just launched a new version of it. It's built on Electron, which I believe is also what like Atom and Particle IOs, or their different IDEs all built on this. So you're real quick here on the screen. If you go over here to Tools, Extensions and Updates, let's go show you what I have. So we have GitHub extension for Visual Studio, Arduino IDE for Visual Studio from Visual Micro. If you search for those, actually we have an update. Yep, Visual Studio is updated, but we'll do that one later. So anyway, again, Arduino IDE for Visual Studio, if you search for Visual Micro, it should show up, and then the GitHub extension and anything that those require. So let's go ahead now, and also, lastly, you need the Arduino IDE. It uses that. So we're not using the IDE interface, but we need the Arduino IDE installed. So make sure you head over to arduino.cc and download the latest and greatest IDE. And that's on their software page, I believe. So anyway, 4 websites you'll visit: visualstudio.com to get Microsoft's Community Edition of Visual Studio, Visual Micro from visualmicro.com, that's the thing that lets Visual Studio program in Arduino, GitHub, and then the Arduino IDE. So once you have all 4 loaded, installed, you'll be able to come into here and go to File, New Project, and specifically you look for Arduino, or whatever, how you pronounce it, project. And let's give this a name. We'll say this is our Visual Micro Test. That's a mouthful, but there we go. So with that loaded, installed, you'll come up with a, if you're used to programming like Visual Basic, it kind of has that feel that Visual Studio's had for many years. If you've never used anything like that, you're coming straight from the Arduino IDE. It might be a little overwhelming. It's certainly not as simplistic user interface, but there's a lot more powerful features to help you write code and do a better job at writing your code and making it easier. So with that, let's go ahead, and what we're going to do basically today, in this demo, we're going to show auto-completion, and we're going to show how to insert breakpoints and step through your code. So basically for that we're going to use down here, we've got a Arduino Uno. We're going to go, let's go ahead and plug that in just so we have it plugged in. Okay, so we have Arduino, we got it plugged in. Let's go ahead and let's get started. So we're gonna, again, the thing we'll do is we'll blink the LED, and we'll pause like 2 seconds between turning it on and turning it off, but we'll insert some breakpoints to show exactly what's going on. So let's go ahead and go, let's define the LED, so pound define. So if you notice that, let's back that up actually. As I'm typing, so if you're coming from the Arduino IDE, it might be a little new if you've done any programming in any sort of, Android, iOS, Visual Studio, then this is kind of old hat to you, but you can basically, if you know, I hit tab, so I didn't actually type the word pound define out completely. I started typing P, D, E, F, and it says, hey, I think you mean pound define. So I go, yep, you're right. I hit tab and it fills it all the way in. Let's do LED, and I believe on the Uno it's pin 13. All right, and we go down into here. All right, so let's first turn on the serial port. So again, serial.b for begin. 9600. Oops, 9600. We'll go give us a little print line here. Welcome to a visual micro demo. ... All right, so let's go ahead and turn pin 13 into an output. And set it low. Oops. Digital right. LED low. All right. Down here in the main loop, since this will loop over and over again, let's do digital right, LED low. Let's pause for a few seconds. Let's do 2 seconds. Let's actually then let's just do it. Digital right, LED high, and then delay 2 seconds. So all this thing does is basically turn the LED on, turn the LED off for 2 seconds, then turn it on for 2 seconds, turn it off for 2 seconds, and does that forever and forever. Actually, let's also go up here. Let's put an integer in here just as like a variable. So let's do int x equals 0. And let's make it a counter. So what we'll do is x plus plus, and then if it reaches, say, 10, we'll set it back to 0, because you'll see why I'm doing that here in a second. This is if x is greater than 9, then x equals 0. All right. Boom, boom, boom. X plus plus. All right. So up here, what we're going to do is we're going to put a print line. So serial ser dot print line. Let's just do print. Let's say breakpoint reached x equals, and then serial dot print line the value of x. And actually, let's not do, we won't put the breakpoint message there. Let's just say x equals, so every time it's going to loop through, it's also going to spit out the current value of x, and then each loop through it increments it by 1 until it reaches 10, and then it resets it back to 0. No logic to it, no reason why we're doing that, just it will show you some of the powers of the debugging or the setting breakpoints. So if we were to run this, all it would do is, and actually let's go ahead and do that. Let's hit save. And let's go ahead and run it. If you notice up here, there's the orange LED that's blinking from the serial communications. Then over here to this side, closer to where my finger is, you'll see pin 13 LED. That'll blink on and off. So let's go ahead and make sure, again up here, visual Arduino 1.6.1.8. We are using an Uno. It is on COM port 4. That's from earlier. Let's change this right now from debug. We'll hit release and tell it to build and update. And down here we'll get any of our error messages. And then what's going to happen is as soon as it starts running, it's over here, it's going to pop up the serial port. Where it should. Let's see here. There it is, view output. Nope, that's not it. View. Here we go. There we go. So next to the COM port, there's this little icon for the serial monitor. It's basically a little rectangle with the Arduino infinite sign. And you'll see here it's counting through. And it's blinking the LED for 2 seconds. And then just dumping out this counter. I want to check something. So if you go over here, so you have your line numbers, and then there's this little gray line that looks just like it's part of the user interface, or like just part of the aesthetic look of the window. But let's go ahead and actually double click it with your left mouse button, and you'll get this little red circle, and that's a breakpoint. And what we actually have to, before we forget, let's go back up here, and where we change this to release, let's make it debug again. Alright, so what's going to happen is now if I hit build and upload, every time it reaches the print statement, the LED, it'll pause there, the LED won't go high. So let's go ahead and show that. So I'm going to go ahead and upload and code. This will clear out and reset. Alright, uploading to the board, opening port, port open. Alright, so x equals 0. So it's ran this line. And notice the LED didn't turn bright. Didn't go high, didn't turn on. Now if you notice up here, there's a new button. It says continue step. So because I put a breakpoint in here, it ran serial.println the value of x, and then it stopped. So if you notice, I'm going to go ahead and click continue and step, and as soon as I do, it's going to start writing the next line, which is to turn the LED on. So I'm going to go ahead and hit that, and boom, the LED comes on, and it goes back off. It increments the counter. Counter's still not greater than 9, so I go back to the top of the loop. I turn the LED low again. I print out the value of x, which is now x should be 1, and guess what? it stopped again. It didn't print the it printed x equals 1 and then it stopped. It didn't turn the LED on. That's pretty cool. So now you can kind of see how you can basically let your code, you know, run to a point. Like you can run it all the way to the point you think it's running correctly, and then hit stop, and then see what your outputs are. Like you can query your variables and just check. So with that in mind, let's take, so that's a basic example. Let's show a little bit more detail. What I can do here, if I hover over that red dot and then I hit the little settings gear, I get two options. I can do conditions and actions. So a condition is basically only do this breakpoint if a certain thing is either true, or when something changes, or a hit counter, basically how many times does this piece of code get hit. But for our purpose, we're going to do a conditional expression that when it's true, and what we're going to say is when the value of our variable x equals 5, then pause. But if it's any value other than 5, continue to work through. So we're going to go ahead and hit close to that. You'll notice now it puts this little, I believe it's a little arrow or a little plus sign, maybe a little plus sign. My eyes are bad and it's really small font. Just letting you know that it's not just a breakpoint now, it's got some sort of logic behind that breakpoint. In this case, again, oops, I didn't want to do that. The condition. So again, let me go there and x equals 5. Yeah, if you double click it, it goes away, or you click it again. So don't do that. So now I'm going to go up here and tell it to stop, and then I'm going to go upload again. Now again, you know, the extra functionality of the debugger is there if you need it, but not necessarily. You know, again, you can do a lot of stuff without it. I think it is pretty cool though. Now just sit here, watch it. X equals 4. The LED's been toggling on and off. X equals 5 and stop. And if you noticed down here, it says in our output window, our project is paused at line 18 of the main loop, which is where we set the breakpoint. X equals 5, and the LED did not go high. So if I hit step again, the LED goes high. It says it's back to running. The counter keeps going. X equals 6, X equals 7. As it's doing that, the LED is blinking. We're going to get to X equals 10. It's going to reset to 0. There we go. And again, now that we're back to 0, 1, 2, 3, 4, we're going to get to 5. And here we go. X equals 3. X equals 4. And the LED's now X equals 5. And stop. So pretty cool. So the other thing we can do here, if we go to settings, we can do actions. So when this is triggered, what do you want to do? In this case, we can tell it to log something, a message to the output window down here. So let's just go ahead and say, I have hit the breakpoint. And now when I hit X equals 5 down here, I'll get that message and then my own custom message. Alright, there it is. And another thing, if you notice, if you hover over your breakpoint, there was the settings gear. There's also the ability to disable the breakpoint without deleting it. So if you just hover over the, looks like 2 circles, and you go ahead and click that, now the breakpoint's disabled. So again, you can set up multiple breakpoints as you're debugging your code and then turning them on and off as needed. So let's just turn that back on. Alright, so the next thing we want to show you is how to put your software under version control with GitHub. So we're going to go over here to the Solutions Explorer. Make sure it says Solution Explorer. You also have Team Explorer and GitHub, but we're going to do Solution Explorer, and then we're going to go to the top, the solution. our project. We're going to right click it, and it says add solution to source control. So we're going to go ahead and click that. Make sure we save everything that we have. Okay, then we hit over here to Team Explorer. You'll notice it says our visual micro test. We're going to double click that. We're going to sync. We want to publish to GitHub. I'm going to make it a private repository for right now, and we'll say description. This is a thrilling demonstration of Visual Studio, Visual Micro, and GitHub. And we hit publish. Boom, 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 boom. We've been successful. And so let's go back out to my GitHub page. And let's go take a look. Our visual micro tests. We click on that. And there's the .ino file. So here is our code that we just wrote. Now up on GitHub, and now we can go back into Visual Studio, make some changes, and continue to push updates as we make them. But that's it in a nutshell. That's using Visual Studio, Visual Micro, the Arduino IDE, and GitHub. Once you've gotten comfortable with the Arduino IDE and you've learned how to program, and you already take that next step to maybe make your coding life a little bit easier or give it a little bit more discipline, this is one option that you can explore. So with that, I'm going to go ahead and end this video now. Thank you for watching. If you've got any questions or comments, please feel free to let me know. If you want me to deep dive on anything more, just let me know. So with that, again, thanks for watching, and we'll see you next time.